Hello students, Happy New Year. Today is the 1st January and this video is about JEE Advanced 2021 question, and the question is from thermodynamics topic. Okay, so let's read the question. Consider 1 mole of helium gas. Helium is a monoatomic gas enclosed in a container at initial pressure P1 and volume is V1. So now look at the figure. I have drawn this diagram. Diagram was not given in question. So since the process is isothermal, so this is P1 V1 value. P1 is the pressure and V1 is the volume, right? So these are initial values of pressure and volume, or we can write it like this also. P1 V1 is the coordinate, initial coordinate. The gas expands isothermally. Okay, so there is isothermal expansion from V1 to 4V1. So your coordinates here will be P2. P2 is not given, and volume is 4V1. V2 is 4V1. Okay, so these are the coordinates here. And after this, gas expands adiabatically. So we know that for adiabatic process the slope is greater and the curve will be more steeper. So you can see here in the second curve, it is volume is becoming 32 V1. So the final pressure again is not given. So let's say P3 is the pressure and volume is 32 V1. This is V3, which is 32 V1. So these values are given. Work done by gas during isothermal and adiabatic expansion are W iso and W adiabatic. So these are work done in isothermal, work done in adiabatic. So what we have to find is ratio of these two things, and that ratio is equal to F log 2, and here we have to find what is F. Okay, so we have to find what is F. Let's see how to do that. Question seems tough, but it's not tough if you go stepwise. So let's think of isothermal curve. This first curve is isothermal part. Okay, so for isothermal process. First part is isothermal, so isothermal process. What we can write for isothermal process, everyone? So we can write PV equal to constant, or P1 V1 equal to P2 V2 equal to P2 V2, P initial V initial equal to P final V final. Okay, so what is initial pressure? P1 only. What is initial volume? V1 only. What is final pressure? P2, which is to be found. Final volume is 4V1. If we put this value, now you can notice that there are some terms that you can cut. So let's cut those terms. This term will go, this term will also go. So what you will have is P1 V1 equal to P2, and V1 will also go. So what we will be having is P2 equal to P1 by 4, right? 4 will be taken on that side. So let me write it properly. So P2, what you will get is P1 by 4. Let's write this equation 1 and let me mark that value here. So this P2 is P1 by 4, or in this axis, on this axis also you can mark it is P1 by 4. Okay, now P3 also we can find using PV raised to gamma equal to constant for adiabatic process. Okay, so let's find P3 also, which will be useful in calculation. So for adiabatic process, for adiabatic process, what we can write is PV raised to gamma is constant. So starting from this point, and end point is P3, 32 V1, that is your end point. So let's write P2, V2 is your 4V1, so I am directly putting the actual values, equal to P3, sorry, equal to P3 and 32 V1, and this P1 V1 raised to gamma. So let's write raised to gamma. So what is gamma here? Let's calculate that gamma. And if you read the question, the gas is which kind of gas it is? It's 1 mole of helium gas. You can read this side. So it's 1 mole of helium gas. You can see it clearly from the question that it is. It's, give me 1 minute. Yeah, it's helium gas. So helium is a monoatomic gas, all of you know this. So for monoatomic gas, what is degree of freedom, everyone? Tell me. So monoatomic gas, you can think of a single particle. It can move in all three directions, x, y, z. So there are three directions. So there are 3 degrees of freedom. Okay. So for monoatomic gas, degree of freedom is 3, and that's why gamma, formula for gamma is 1 plus 2 by degrees of freedom, f. So this will be 1 plus 2 by degree of freedom is 3. So your gamma value will be 3 plus 2, 5. Cross multiply this. So 5 by 3 you will get, that's value of gamma. Fine. So now let's use this value of gamma here. So P2 is also given P1 by 4. P2 we have calculated here. You can see P2 is P1 by 4. So let's write that value, P1 by 4 into 4 V1 raised to gamma. What is gamma? 5 by 3. And we are interested in P3. So let's take this 32 V1 raised to gamma also on this side. So what we will have, gamma power you can take common. Gamma power you can take common. So this is power gamma, which is 5 by 3. And this will be 4 V1 on this side, and 32 V1 will come in the denominator. Okay, check my calculation. Are we going right? So this and this you can cut, and 4 ones are 4, 4 eights are 32. So what we have now, we have P3 equal to P1 by 4, and this is 1 by 8 raised to 5 by 3. So you can take first cube root of 8. And what is cube root of 8? Cube root of 8 is 2. And what is the next power? Next power is 5. Okay, you can see it is 5 by 3. So I have taken cube root first. So cube root of 8 is 2. And then 2 raised to 5. 2 raised to 5 is 32. So you can write this as P1 upon 4 into 32. Or you can write, if you want, 128 also. 4 into 32 is 128. Correct. So now we have all the values which are required. Now let's find the work done, as they are asking work done in iso upon work done in adiabatic. So you should know the formula directly. Work done in isothermal divided by work done in adiabatic. So formula for work done in isothermal is nRT log of V final upon V initial. Let me write the formula first, and then we will put the value. And work done in adiabatic, there are two formula. We will use the pressure formula, PV formula. So P final, V final. So here final volume is final, and pressure and volume is P3 V3. So we will use P3 V3 minus P initial V initial is P2 V2. So P2 V2 upon gamma minus 1, and there is a minus sign. P final V final minus P initial V initial upon gamma minus 1 with a minus sign. Okay, so what we will have, and nRT you can write PV. So in first case pressure was P1 V1, so you can write P1 V1 in place of nRT log of V final. So look at this first graph, these are the initial and final values. So you can write 4V1 is final volume and initial is V1. So in step number 1 it was 4V1 by V1. Remember, this is natural log, divide by minus P3 V3. So what was P3 V3? Just now we have calculated P3 was P1 by 128, this value. Okay, so P1 by 128. V3, what was V3 volume? 32 V1. You can see the graph, 32 V1. This is P3 V3 minus P2 V2. Put a bracket also so that you won't get confused. So P2 V2 is, P2 was P1 by 4, and P2 was P1 by 4. V1 V2 was 4 V1, and gamma is 5 by 3, so 5 by 3 minus 1. So let's simplify this, and this will give us answer. So let's solve. P1 V1 you can write this log 4, see this v1 will get cancelled, this will cut out. Okay, so what we are left with is 4, log 4. So log 4 you can write log of 2 square. Okay, and divide. Why I am doing this? Because the options are like that, the answer they want in terms of log 2, that's why I am converting log 4 into log 2. Okay, minus sign you can keep here. 5 by 3 minus 1 is 5 minus 3, 2 by 3, so that 2 by 3 is in denominator, so you can multiply numerator by 2 by 3. Okay, so what we have here is p1 v1 you can take common. Inside bracket what you will have is 32 upon 128 is 1 by 4, minus 4 and 4 gets cancelled, so this is 1. So 4 1 minus 4 is minus 3 by 4, minus of minus becomes plus, this you can cut, so plus 3 by 4 in denominator, and this is 2 by 3, and this is log of 2 square you can write 2 log 2. So this is 2 to the 4 by 3, and you can multiply this 4 3 by 4 as 4 by 3. So what you have is this into log 2. So this is your 16 by 9 log 2, and this is your f log 2. As per the question it is f log 2. Read the question again, last line. So the ratio is f log 2, so value of f will be 16 by 9, but they want answer in decimals, so let's convert. This f is your 16 by 9, this is the answer, but we want to convert this into decimals, so let's convert it. Just do the simple division. Orally also you can do, but let's do it stepwise. So 16 by 9, so 970.97 again 7, so this is 7 non-terminating, so you can write f is 1.777 dot dot dot. If you round off it to 2 decimals, so this comes out to be 1.78. Up to 2 decimal you can round off as per the question. Okay, so your answer is 1.78. That's it. Okay, if you like the solution, and if you want to comment anything about the solution or any step you are not sure how I got that step, so just comment and share this with your friends so that they will also get benefit of the solution. Okay, thank you all. Bye bye, have a nice day.